Hello everyone! This video is entitled Transition Metals. In this lecture, I will walk you through the process of writing out the chemical formulas of ionic compounds that contain transition metals with more than one charge, and show how to properly name ionic compounds that have these multivalent metals within them. If you have not yet watched my video on writing and naming ionic compounds, it is recommended that you do so first to fully understand this material. You can find a link to that video in the description below. Okay, let's get started.
So the best way for me to explain the need for a new type of naming system for ionic compounds that contain transitional metals with more than one charge is through an example. Here I have iron chloride. I'm going to write out the chemical formula for iron chloride using the rules I provided to you in a previous lecture. First, identify the metal and nonmetal. So iron is clearly the metal and chlorine is the nonmetal. Second, write the symbols. The symbol for iron is Fe and the symbol for chlorine is Cl. Third, write the charges. And so I know that the charge on chlorine will be 1 negative, but what is the charge on iron? Well, therein lies the problem. Iron has the potential of having 2 possible charges. It is considered a multivalent element. The word multivalent implies that iron is capable of ionizing to create 2 different kinds of ions. One ion could potentially have the charge of 2 positive, while the other could have the charge of 3 positive. So which one do I use here to write out this chemical formula? Well, let's move on to see how. Nearly all the transitional metals, that is, the metals in groups 3 to 12, are able to form more than one cation. In the case of iron, as I mentioned, it can form a cation with a 2 positive charge or a 3 positive charge. And so it begs to reason that when you write out the name of an ionic compound that contains iron in it, or any one of these transitional metals that have more than one charge, you must include the charge that is in that compound. Or else, you would be incapable of writing out the chemical formula for that compound. And so, let's try writing out the chemical formula for iron chloride again, but this time we'll use each charge separately and see what we get. Here we have iron 2 chloride. Now, of course, the 2 represents the charge. Now, I included the charge for iron, but I did not include the charge for chlorine. This is because chlorine is a nonmetal, and there are no nonmetals that have more than one charge. You are never to write the charge of an element in the name when it only has one possible charge, and this of course applies to metals as well. So if this was sodium chloride, I would not include the charge of sodium because sodium is only capable of having one charge. And so because iron is multivalent, as I mentioned, and it could have more than one charge, that's the only reason you include the charge in this name. So again, the charge is only included in names with metals that have more than one charge. And so let's see how we can write the ionic chemical formula for this compound. First, we identify the metal and the nonmetal. So of course, iron is the metal and chlorine is the nonmetal. Write the symbols. Symbol is Fe for iron and Cl for chlorine. Write the charges. And so now we can write the charges for both these elements because it's indicated in the name for iron. Now we cross over the charges. Remove the charge symbols. Simplify the values and remove the ones. And write the chemical formula. And so the chemical formula for iron 2 chloride is FeCl2. Now here we have iron 3 chloride. It's going to be the exact same process, but you'll notice that you will get a different chemical formula because iron has a different charge. And so this, of course, emphasizes the importance of writing the charge within the name of the ionic compound. And so we identified the metal and the nonmetal. We write the symbols. We write the charges, we cross them over, remove the charge symbols, simplify, and write the chemical formula. And so you can see here that the chemical formula for iron 3 chloride is different from the chemical formula of iron 2 chloride. Here the chemical formula is FeCl3. So how do we formally name metals with more than one charge? It doesn't seem appropriate to put the charge symbols in the middle of an ionic compound name. Well, there are two ways to name the cations of a multivalent metal. First is the classical system, and second, the stock system. Let's take a look at the classical system first. The classical system is based on the Latin name for metals that form more than one ion. Now bear in mind, before English became the dominant language on Earth, Latin was the language that most people spoke. And so, of course, during the formative years of discovery in science, Latin was used to name many of the elements that we now know on the periodic table. Some of them have been translated into a more common tongue, or an English word, but the Latin names still stand for some, and the symbols are remnants of the use of this Latin name. So, for example, iron, symbolized by Fe, was actually called ferrum. Copper, which starts with Co, is symbolized Cu because it was once called cuprum. And lead, symbolized by Pb, was actually called plumbum. The rules for the classical system of naming are actually quite simplistic. You take the Latin name of the element that ends with the letters or and you drop it and replace it with a new suffix. A suffix is the ending of a word. Now, the new suffix will indicate whether you're describing an ion with a high charge or an ion with a low charge. If you're describing the ion with a higher charge, the suffix "ic" is applied to the Latin name. If you're describing the ion with the lower charge, the suffix "us" is applied to the Latin name. Let's revisit iron, copper, and lead. The Latin name for iron is ferrum. Now remember, iron has two possible charges. It can have a lower charge of 2 positive, or it can have a higher charge of 3 positive. If we're describing the lower charge for iron, the ending from the Latin name is dropped and replaced with a new suffix, ous. The name for this iron would be ferrous. If we're describing the higher charge on iron, the suffix is dropped and replaced with ic, and so the name for this iron is ferric. Copper is called cuprum. Its lower charge would then change the name to cuprous. Its higher charge would be called cupric. And lead, Latin name plumbum. Its lower charge would have the Latin name plumbus. Its higher charge, plumbic. Some of you may be sitting there wondering, how is it that I'm to know the Latin name of every element on the periodic table? Well, of course, that would be an outlandish request from my end, and really an outlandish expectation made by the scientific community. The reason why it's so important for you to know the classical name or Latin name of certain elements on the periodic table is because those Latin names oftentimes still appear in scientific text. And so, to avoid confusion in the future, it is important for you to know these names so that you have a firm grasp on the nomenclature or the naming of these types of elements. The 7 elements that most readily appear in scientific text as a Latin name are copper, iron, mercury, lead, tin, chromium, and cobalt. These are the 7 elements for which the Latin names are just as important to know as the stock name. Now, of course, the stock names are things that we will go into in the coming slides. But in this table, you can see that I've provided you with the ions and their ion charges, along with the classical names that coincide with them. This table summarizes the classical names or the Latin names that you need to know. The stock system of naming. The stock system is the most current system for naming ionic compounds, and in fact is the formal accepted system for naming. The stock system uses the English names of the elements rather than the Latin names. If a metal can form more than one cation, the charge used in bonding is written in brackets as a Roman numeral after the name of the metal. And so if the charge, for instance, is 4, the Roman numeral would be IV. If the charge is 2, it would be II. And if the charge happens to be 7, it would be VII. These are, of course, the Roman numerals that you will need to know for the stock system. Once again, we have a compound here made up of iron and chlorine. This compound contains the iron ion with a lower charge, 2 positive. Using the classical system, this compound would be called ferrous chloride. The ending OUS is used to indicate the lower charge on the iron ion. Using the stock system, this compound would be called iron II chloride. The Roman numerals in brackets II indicate the 2 positive charge on iron. In this example, the compound is using the iron ion with a higher charge. Using the classical system, this compound would be called ferric chloride. The ending IC is used to indicate the higher charge on the iron ion. Using the stock system, this compound would be called iron III chloride. Again, the I in brackets is a Roman numeral used to indicate the 3 positive charge on iron. Here are some practice questions that we will run through together to make sure that you have a firm understanding of the 2 new naming systems. But before we name these compounds, it is important to take note of the fact that sometimes it is very difficult to identify the charges on the elements within a chemical formula because of the simplification these chemical formulas undergo when they are being written. And so in the process of answering these practice questions, I will walk you through the steps that you need to take to break apart these compounds and identify the charges that are on every single element in the compound. The chemical formula here is PbO2. Now we know this compound contains lead and oxygen, but it may prove very difficult to name this compound because we are unsure of the charge on lead. Now some of you may be wondering why that is. You may be thinking, oh, well the charge must be 2 because of the crossover rule. But if that's the case, then the charge on oxygen is 1. But we know that can't be the case because oxygen has a charge of 2, cannot have a charge of 1. And so obviously this compound formula has undergone some form of simplification when it was being written. And so there are 6 simple rules that I will teach you right now to break apart this compound and really figure out the true charge on lead. First, separate the 2 elements. Second, add a 1 to the element that has no number. And so lead has no number, so I add a 1. Cross over these numbers from bottom to top. And so this is the opposite of the crossover rule. Add the charges. Now remember that metals, those are the elements that come first in the chemical formula, are positive, and nonmetals that come second are negative. Now, The most important rule is rule number 5. You need to make sure that the charges of each element match those found on the periodic table. If they do not, you multiply both charges with the same number to reach the true charge of the nonmetal. And so, of course, lead has a charge of 2 positive on the periodic table, but oxygen does not have a charge of 1 negative. Oxygen can only have a charge of 2 negative. And so because of that, I must multiply oxygen by 2 to achieve the true charge. But what I do to oxygen, I must also do to lead. And so I will multiply both of these elements by 2. And when I do multiply them, I get a new charge for lead, that is 4 positive, and the true charge for oxygen, which is 2 negative. Both of these match the periodic table, and so now I can move on to step number 6. Write the compound name. And so because I have the true charge on lead, and I know its charge will be 4 positive, I can name it using the classical system, and I can use it naming the stock system. And so the classical name will be plumbic oxide, and the stock name will be lead IV, indicating 4 oxide. The next example we have is the chemical formula Cu2S. Now clearly this compound contains copper and sulfur, but can we be sure that the charge on copper is 1 and the charge on sulfur is 2? Well, let's break this compound apart using the rules and make sure. Separate the two elements. Add a 1 to the element that has no number. Cross the values up from bottom to top. Add the charges. So of course the metal will be positive and the non-metal will be negative. Rule number 5. Make sure the charges of each element match those found in the periodic table. If they do not, multiply both charges with the same number to reach the true charge of the non-metal. And so when looking at these two charges and looking at the periodic table, I know that sulfur will have a charge of 2 negative and that copper indeed can have a charge of 1 positive. And so they do match the periodic table, and I can move on to step number 6. Write the compound name. And so the classical name for this compound will have the ending OUS because copper's lower charge is 1 positive and its higher charge is 2 positive. And so the classical name will be cuprous sulfide. The stock name will be copper I sulfide or copper 1 sulfide in Roman numerals. For our third example, we have the chemical formula FeO. Now, of course, this compound contains iron and oxygen, but what is the charge on iron? Based on the chemical formula, the charge on iron should be 1, and the charge on oxygen should also be 1. But this does not seem correct. Iron does not have a possible charge of 1, and so clearly this chemical formula has undergone some kind of simplification in the process of being written. And so by applying the rules, we can separate this compound and tease out the true charges for these elements. So step 1, separate the two elements. Step 2, add a 1 to the element that has no number. So both of them have no number, and so both of them get the value 1. Cross these values up from bottom to top. Add the charges. The metal will be positive and the non-metal will be negative. And rule number 5, make sure the charges match those on the periodic table. And so oxygen does not have a charge of -1 on the periodic table. Oxygen can only have a charge of 2 negative. And in fact, iron cannot have a charge of 1 positive. It can only have a charge of 2 positive or 3 positive. And so when looking at the nonmetal, I need to multiply both these elements by a factor of 2 to arrive to the true charge of the nonmetal. Now remember, the nonmetal is what is important here, because it is possible that you could have a metal with a charge that matches the periodic table, but if the nonmetal does not match, then your charges are off. And so I'm applying my calculation based off of oxygen, not based off of iron. But what I do to one element, I must do to the other. And so if I'm multiplying oxygen by 2, I'm also going to multiply iron by 2. And so by doing this, I arrive at a charge of 2 positive for iron and a charge of 2 negative for oxygen. And both of these charges, in fact, do match those on the periodic table. And so I can move on to rule number 6. Write the compound name. And so because iron has a low charge and a high charge, and its low charge is 2 positive, I know its classical name will have the ending OUS. And so the classical name for this compound is ferrous oxide. The stock name will be iron double I oxide, or the Roman numeral 2 to indicate a 2 positive charge. For our last example, we have another compound that is composed of iron and oxygen. The chemical formula for this compound is Fe2O3. Now, it does seem to have charges that are in line with those of the periodic table. Iron does have a charge of 3 positive, and oxygen does have a charge of 2 negative. But let's separate these compounds using the rules to validate what we suspect. So we separate the compounds, add a 1 to any element that has no number. Both of these elements have numbers, and so we can ignore rule number 2. Cross these values up from bottom to top. Apply the charges. Make sure these charges match those on the periodic table. And in fact, they do match those on the periodic table. And so we can move on to rule number 6. Write the compound name. And so because iron here has the higher charge of this element, its classical name will be ferric oxide. And the stock name will be iron triple I oxide, or Roman numeral 3 to indicate the 3 positive charge. And with that, we arrive to the practice questions I've picked out for writing out chemical formulas. We will also be walking through these questions together to make sure that you fully understand how to write the chemical formulas of compounds that have multivalent metals. And so for our first practice question, we have the name iron, Roman numeral 3, bromide. Of course, the Roman numeral 3 represents the 3 positive charge on the iron element. And so the first thing we're going to do is we're going to identify the metal and nonmetal, write the symbols, write the charges. And so because we have the charge in Roman numerals, we know that iron will be 3 positive, and bromine is always 1 negative because of its placement on the periodic table. And now we cross the charges over from top to bottom, remove the charge symbols, simplify the numbers and remove the ones, and we put it all together. And so the chemical formula for the name iron, Roman numeral 3 bromide, is FeBr3. And so for our second example, we have nickel, Roman numeral 3 phosphide. First, identify the metal and the nonmetal. So nickel is of course our metal and phosphorus is our nonmetal. Second, write the symbols for these elements. Third, write the charges. And so because of the Roman numeral 3, we know that nickel will have a charge of 3 positive, while phosphorus will have a charge of 3 negative because of its placement on the periodic table. Cross the charges over from top to bottom. Remove the charge symbols. And rule number 6, simplify the numbers and remove the ones. Now looking at this point in the slide, can you simplify these two values any further? And of course you can, because they're both 3, and by dividing both these values by 3, I can replace them with 1s. And so I'll do that. Now that I have the values of 1, I can remove those 1s when putting this chemical formula together. And so when I write the chemical formula, it is written as NiP. This next example is manganese, Roman numeral 4 oxide. Now, identify the metal and the nonmetal. The manganese is, of course, the metal, and the oxygen is the nonmetal. Write the symbols for these elements. So manganese is Mn, and oxygen is O. Write the charges. And so because of the Roman numeral 4, I know the charge on manganese will be 4 positive, and oxygen, of course, is 2 negative because of its placement on the periodic table. Cross the charges over. Remove the charge symbols. And rule number 6, simplify the numbers and remove the ones. Can I simplify these two values any further? Well, because they're both multiples of each other, I can divide both these values by 2 and arrive at a 1 for manganese and a 2 for oxygen. Now I just simply remove the 1 and write the chemical formula as MnO2. And for my last example, I've given you the chemical name plumbic sulfide. I've thrown you a bit of a curveball here because I've used the classical system of naming for this compound. Originally called plumbum to represent lead, the ending ic is indicative of the higher charged ion for that element. And so plumbic indicates the higher charged ion of lead. So first, we're going to identify the metal and the nonmetal. Second, write the symbols for these elements. And so the symbol for lead, or plumbic, is Pb, while the symbol for sulfur is S. Write the charges. And so again, the ending Ic indicates the higher charge for the lead ion. And so looking at the periodic table, I know it to be 4 positive, while sulfur is always going to be 2 negative because of its placement on the periodic table. Cross the charges over from top to bottom. Remove the charge symbols. And rule number 6, simplify the numbers and remove the ones. And of course, we can simplify here by dividing both values by 2. Doing that, I leave lead with a 1 and sulfur with a 2, so I can remove that 1. And when I write the chemical formula, I'm left with PbS2. And with the conclusion of this slide, I come to the end of this lecture. I hope you understood everything I discussed today. Thank you for listening. All the best.